All right, we're going to talk about solutions. So let's start with a few definitions. First of all, a solution from grade 9, remember, it's a homogeneous mixture. It looks the same throughout. Made up of two parts. The first one is the solvent, which is there in the greater quantity. And then secondly, the solute, which is there in the smaller quantity. So what you do is you dissolve your solute into the solvent. Example of that would be sugar and water. Sugar is the solute, water is the solvent. Now, when you can dissolve a certain amount of the solute in a certain amount of a solvent, then you have this idea of solubility. An example, oil is insoluble in water, and sugar is highly soluble in water. So let's also talk about some of these factors that affect the solubility. What is it that we're looking at when we say something is really soluble or something is not so soluble or something is insoluble? That depends on the intermolecular forces between the solute and solvent particles. The two types of forces that we're going to deal with are essentially the dipole-dipole attractions between polar molecules and the ion-dipole attractions between ions and the polar molecules. Golden rule is essentially like dissolves like. So what does that mean? Well, if you have a polar substance and you put it into a polar solvent, then you're going to end up having the solute dissolved in the solvent. If you try and put a nonpolar substance, like an oil or something like that, into a nonpolar solvent, let's say paint thinner or something like that, then you will also be able to dissolve the solute in the solvent. If you try and do it with opposing things, so a polar substance in a nonpolar solvent, it's not going to dissolve. Or if a nonpolar substance into a polar solvent, then it's not going to dissolve. So how do we figure out if we've got a polar substance? So review from first unit. Remember, we use the electronegativity difference and the molecular symmetry to determine if it's a polar substance or if it's a nonpolar substance. Now we run into an issue with ionic compounds. Ionic compounds that are really strongly attracted to each other may not dissolve well in water. And that's the reason is simply because the two ions are more strongly attracted to each other than they are to the positive or negative end of the water molecule. Now, other things that affect the solubility of a substance, size, the type of molecule and the size of the molecule. It's far easier to dissolve smaller particles. And so as the particle size decreases, solubility increases. And that has to do with the surface area that's exposed to the molecule that's in the solvent. The greater surface area that's available, the more interactions between the solute and solvent particles, and the easier the solvent particles can surround the solute particles and bring them into solution. Temperature. That also has an effect but different substances are affected differently. Essentially, temperature is the average kinetic energy of the molecules. And so the quicker they move, that has a result on solubility. So, for solids, for example. As you increase the temperature, the solubility increases as well. And that's because the molecules are able to move around faster and surround the solute particles and bring them into solution more quickly. So that increases the solubility. Liquids, though, really there's no effect. So if you put a liquid solute in a liquid solvent, there really is no effect. It doesn't change how quickly the two solutions dissolve in each other. With gases, it's actually the reverse, because with gases, when you excite those molecules, it's far more difficult to bring them into solution. They tend to escape the surface of the solution far more quickly. So why is that? The energy breaks the solid particles apart, and so the increased kinetic energy decreases the solubility of gases. Pressure is also something that has an effect on solubility. With primarily gases, you really don't have much of an effect on solids and liquids. But for gases, if you increase the pressure, then you can increase the solubility. The reason is that gases are already very high energetic states for the particles. And so if you want them to dissolve into a liquid, you actually have to force them into the solution. And that's what the pressure is about. It increases that force into the gases of the into the solution of those gas particles. All right, the next topic we have to do is when you have the maximum amount of solute dissolved in a solvent. All right, this is when we have what we call a saturated solution. So an unsaturated solution, you can still dissolve more solute into the solvent. Saturated solution, you've reached the maximum amount. You can't dissolve anymore. There's a special case where under certain circumstances and with only certain types of particles, because this can't be done with every single type of particle, that you can actually dissolve a little bit more solute than is theoretically possible at that particular temperature and pressure. When you can achieve that, you've got a situation where you've got a supersaturated solution. Now be careful with this because this one is quite often mistaken for being a situation where you have more than the given amount of solute that can dissolve in a solvent in that solution. Now, if it's all dissolved, yes, you have a supersaturated solution. What usually happens is that you have a saturated solution with extra stuff sitting at the bottom of the beaker. And so when that happens, then you have not a supersaturated solution, but a saturated solution with some leftover solute. And so you need to be able to differentiate between those two situations. So be careful of that one. How do we figure out? Well, people have already done the work for us, and so we have these solubility curves. And there's in your textbook, there's also a variation on this, where we have a substance, and we can see that at given temperatures, and usually these are set for a certain amount of solvent, right? The curves essentially tell us how much of that substance can be dissolved at a given temperature. And in this case, it's per 100 grams of water. So this potassium chloride, for example, table salt, sodium chloride, for example, table salt, at 20 degrees Celsius, we can dissolve about 35-ish grams of salt per 100 grams of water. If we increase the temperature to, let's say, 60 degrees, now we can dissolve about 37 grams, so a little bit more. And you'll notice some of these change quite significantly, and then sometimes you have salts that, for example, this cesium sulfate here, it has actually a negative. So as you increase the temperature, there's suddenly you can't dissolve anymore. Okay? So this work is done for you, but you need to be able to glean information from this, and there are some textbook questions in the homework that will give you some practice on that. These make really nice test questions, so you will always see these on the test. Okay. All right, so there's today's homework. That'll be it for probably the next couple of days, and we'll I'll probably post a little bit more later this week. Rather than give you a quiz, I think we'll just move on to the next section. All right, enjoy. Ask questions. I will open up a chat, and we'll probably on Wednesday or Thursday have a chat session for you to ask questions.